Hi guys, very good morning. Welcome to the session. Myself Dinesh. So this session is a third session on random variable series. So in this week, I'm taking a series of classes on random variables. So in the last two classes, I've covered the concepts of probability density function and cumulative distribution function. Okay. In today's session, we're going to cover moments of random variable, a concept called moments of random variable. Okay. So very important concept. So let's move ahead. So this is my profile. So you can observe that I teach subjects communication systems and signals and systems. These are my subjects of expertise, and this is my Telegram group. So if you wish to ask me any doubts, you can post it in this group, so I can help you guys with those doubts. Next, so let's start with, before starting the topic, I'll show you what is the topic that I'll be discussing today. What is the agenda of today's session? So first I've given some homework questions in yesterday's session based on cumulative distribution function. So two questions I've given. So I'll solve them first quickly, and then we'll move on to the topic of moments of random variable. Moments, we also call it as expectation of random variable also, or we also call them as statistical averages. There are different names for the same thing: moments, statistical averages, or expectations. So next we'll talk about properties of moments, and then I'll give you some homework questions as well at the end of the session. Okay, right. So these are the two questions that I've given as homework in yesterday's session. So discrete random variable x takes values 3, 4, 5, 6, 7 with equal probabilities. Plot CDF of x and find CDF function value at x equal to 6. Okay, so probability also we can plot, PDF also we can plot, CDF also we can plot. So CDF, I'll try to plot it directly. Because discrete functions are easy to plot. So CDF is cumulative distribution function, capital Fx of x. This is the notation that we take as a function of x. Fx of x is what they're asking us to find. So let's plot from traveling from minus infinity. 3 is the first number that has some non-zero probability. So till 3, CDF also will be 0, because before 3 there is no number that is taken by the random variable which has a non-zero probability. So at 3, the CDF has something to accumulate. So what is the probability? There are 5 numbers here. 5 numbers are taken by this random variable, and they said saying that all of them are having equal probability. So the probability of all of these numbers are equal, which is 5 numbers. So the probability of each of these numbers is 1 by 5. Okay. So 1 by 5 is the probability accumulated at 3. 1 by 5. So just after 3 till 4, there is no other number which has non-zero probability. So from 3 to 4, there is no number which has non-zero probability. So when certain numbers have no probability, zero probability, then what happens? CDF will stay constant. Next, at 4, they have some non-zero probability 1 by 5. So CDF will accumulate that. So this is 1 by 5. This will be 2 by 5. Next, from 4 to 5, there is no number which has non-zero probability. So it will stay constant till 5. And at 5, there is something to accumulate. 5 has non-zero probability of 1 by 5. CDF means accumulated probability. As you travel from minus infinity to plus infinity, whatever probabilities are there, you just accumulate them and plot it. So at 5, there is some probability to accumulate. So it will become 3 by 5. Next, at 6, there is something more to accumulate, 4 by 5. And at 7, there is something more to accumulate. It will become 5 by 5, or it is 1. So I've plotted directly CDF because this is discrete case, which is easy case. That is why I've plotted directly. If you are comfortable plotting CDF only using PDF, you can plot the PDF of this one, right? It is easy to plot the PDF of this. At 3, we have an impulse with a height of 1 by 5. At 4, we have at 5, 6, 7. At 3, 4, 5, 6, 7, they're having probabilities of 1 by 5 each. So this is the PDF. So first you can plot the PDF. From PDF you can plot the CDF. Anything is fine. Next, find the CDF function value at x equal to 6. There are two ways to find it. fx of 6. This is what they're asking us to find. If you already have CDF, look at 6. 6 means 6 included. The mean definition of CDF is, fx of x naught is p of x less than or equal to x naught. So it means you're going to include the probability of x naught also, because there is an equal to sign here. The definition of CDF indicates the accumulated probability till x naught included, right? So if it is 6 here, probability till 6 should be included. So at 6 there is an accumulated probability of 1 by 5. So just after 6, what is the value? It is 4 by 5. You might be confused because at 6 there is a discontinuity. When there is a discontinuity, it is difficult to say the value. So the value is undeterministic, right? So but when you're talking about CDFs, so whenever they're asking the value at the discontinuity, what you can do is just take the value after the discontinuity. Just take the value after the discontinuity. Why? Because the definition says so. Fx of x naught means x less than or equal to x naught. The probability of 6 also should be included. Probability of 6 also should be included. So if you observe, before 6, the probability of 6 is not included. After 6, the probability of 6 is included. So that's why take the CDF value after the number, just after the number, to find the CDF value at a particular point. When there is a discontinuity, take the value after that point. Right? So what is fx of 6? From this you can find it as 4 by 5. That is one way. Or fx of 6 means, what is the definition of this? Fx of 6 means probability that the random variable takes values less than or equal to 6. Less than or equal to 6. All these values of random variable, we want the accumulated probability. So add up all the probabilities till 6. 6 included. Add up all the probabilities. There is no probability here. 3. There is one probability, 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5. 4 1 by 5s to be added. So fx of 6 is probability of all the values of the random variable, probabilities of all the values of the random variable accumulated till 6. So all these 4 values added, it is 4 by 5. You can find that using CDF or PDF. Okay. Right, next one. So continuous random variable x takes values 3 to 7 with equal probabilities. So here they are talking about uniform PDF. 3 to 7, it takes uniform probabilities or equal probabilities. As a function of x, we can plot the PDF. Here it is continuous random variable. Mind this is a continuous random variable. Earlier I've shown you similar example, 3 to 7 only, but it is discrete random variable. There is a difference. So continuous random variable means it takes all the real values from 3 to 7, all the real values. There are infinite such values in between. So all of them are having equal probability. So what should be the height of this PDF? Height of this PDF, because the PDF has this property that says area of the PDF should be equal to 1. If you want the area to be 1, what should be the height? Width is 4 units, so the height should be 1 by 4 units, then only the area will be 1. Only if the area is 1, then only we can call it as PDF. Because we are plotting the PDF, we have to put the height in such a manner that the area will be 1. Okay, right, we got the PDF. Next, how about the CDF function? CDF, let us plot. CDF we can plot using PDF, using integration. Fx of x is what we want to find. Capital Fx of x means it's accumulated probability. So from minus infinity till 3, there is nothing to accumulate, no probability to accumulate, so it will stay constant at 0. And after that, from 3 to 7, so accumulation of these probabilities from 3 to 7, accumulation means for continuous case it is integration. I'll write the definition here. Fx of x is equal to integration from minus infinity to x, small fx of x dx, just integration. So what is the integration of a constant? Constant 1 by 4 integrated, it becomes 1 by 4x. It becomes 1 by 4x. So it increases, and after that there is nothing to accumulate. So if the upper limit x is any value more than 7, after 7 there is no area to include, so that's why it will stay constant at 7. And because it is CDF, we know this value will become 1. CDF, after a certain value of random variable, it will become 1. After certain value. What is that value? That we don't know. That value depends on the PDF. Or that value is the highest value of the random variable which has a non-zero probability. See this one here, 7 is the highest value of the random variable which has non-zero probability. Here also 7 is the highest value of the random variable which has non-zero probability. After a certain value of random variable which has non-zero probability, after that point CDF will be taking a constant value 1. Okay, Right, I've plotted the CDF. So plot CDF of x, that is done. Find the CDF function value at x equal to 5. So they're asking us to find fx of 5. Fx of 5, you can see here what happens. 3 to 7, 5 is the midpoint. So from 0 to 1 it is going, 5 is the midpoint. So the midpoint should have a height of definitely half. So the answer should be half. From CDF we can find it easily because they're asking CDF function value at certain point, which is very easy to find if you know CDF. But how about if you know PDF? If you know PDF, the meaning of this is, see this one, fx of 5 means from minus infinity to 5, you have to integrate this function. From minus infinity to 5, integrate the PDF function. Integrate the PDF function. And how about that? From minus infinity till 5, just integrate it. Which means they're asking us to find from area from minus infinity to 5. From minus infinity to 3, there is no area. So effectively, they're asking us to find the area from 3 to 5. So this area. 3 to 5, the width of this rectangle is 2 units, height is 1 by 4. So 2 times 1 by 4 is 1 by 2. Is that okay? So that is the answer. Shall we move on to the next question? So questions are done, homework questions are done regarding CDF. We'll move on to today's topic, which is moments of random variable. So observe carefully. I'll explain in very detail what is the meaning of this, what are the properties of moments, and we'll solve some questions as well. So moment of a random variable is the weighted average of values taken by the random variable, and what, with respect to what we weigh them, we weigh them with respect to their probabilities, or as simple we can say it as statistics also, you can say. Okay, we can simply say it as statistics also. I'll just take some example which you might have learned in very lower classes, statistics classes, right? Sir, we have not taken any statistics subject. No, we don't need to take any statistics subjects in our classes like 8th, 9th, 10th classes. We'll have in mathematics itself, we'll have some chapters with the name statistics where we learn about mean, median, mode, something like that, right? So in that I'll take a small example. Marks of students and number of students. Okay, so total number of students is, let's say, 100. Okay, now a student, there are many students who got 80 marks. And how many students got 80 marks? And that is statistics. I'm giving some statistics. Based on that, we'll find some average. Let's say 20 students got 80 marks and 70 marks. 50 students got 70 marks. 60 marks, 10 students got. Okay, 50 marks, also 10 students got it. Total 50, 60, 70, 80, 90. 90 marks, around 10 students got. So total number of students is 100. Okay, just for example's sake, not every student will get 80, only 70 or 60. They might get in between also. But just for the example's sake, I'm saying there are 20 students who scored 80. There are 50 students who scored 70, 10 students who scored 60, and so on. Now, as a person comes to school and he asks me, what is the performance of the student? Then you can't read out all these statistics, right? So this is statistics, the information. Okay, you can't read out all these statistics. 80 students got 20, 70 students got 50. The information. You can't read out all these statistics. 80 students got 20, 70 students got 50. You can't read out all these statistics. 80 students got 20. Okay. Right. So we have to tell them the information in a crisp manner, in a short format, right? So what will you say? You can't say all these, you can't read out all the statistics. So instead of saying all these details, you'll say some average value. Instead of saying all this, this total information represents the information of a class, but this is huge information. To convey to someone, this is huge information. They may not be interested in all that information. So what we will do is, we will find some average marks. average marks. Okay, so how do we find that average marks? If you remember, this is how we used to find it. We do a weighted average of marks. So 80 we multiply it with its weight. What is the weight? How many students got 80? 20. So we multiply that 80 with 20. So we're weighted. We're multiplying the value that we want to average. We want to average marks. Whatever we want to average, we are multiplying with its weight. Okay, next 70 is the marks. This 70 is also possible. So marks we want to average. Whatever marks, these are the marks possible. And these marks we want to average. Whatever you want to average, multiply them with the weights. So 70 multiplied with 50 plus 60 marks. Also we have to average, and its weight is 10 plus 50 also we want to average, and its weight is also 10 plus 90 also we want to average, and its weight is also 10. Now what we do? When we are multiplying with weights, we don't get the average. Okay, we have to divide with the total number of students, total weight, which is 100. This is how we calculate average. If you remember, statistical average. Using statistics, this is how we find average. This is a simple example from lower classes. So now let me just convert this example into a more easy format to understand. Now what I'll do is just divide it by 100. I'll write it individually for each one. So see here, there are 5 terms being added here. 1, 2, 3, 4, 5. 5 terms being added. All of them are divided with 100. Now what I'll do is I'll put this 100 in everywhere. Instead of writing by total by 100, I'll write this 100 for every term. 20 by 100 plus 70 into 50 by 100, 60 into 10 by 100 plus 50 into 10 by 100 plus 90 into 10 by 100. See this? Now, if you look at this one, is it not looking like 80 into 0.2 plus 70 into 0.5 plus 60 into 0.1 plus 50 into 0.1 plus 90 into 0.1? See this one? Is it not looking like probability? See this? Is it not looking like probability? And the total probability should be 1. See this one? 0.2 plus 0.5 plus 0.1 plus 0.1 plus 0.1 is 1. Is it not looking like we want to average marks and we are multiplying those marks with their corresponding probabilities? Okay, 0.2 is not probability here. Okay, because probability we get it from statistics only, the same way. How we have found 20 students got 80 marks. So 20 out of 100 is 0.2. Yes, that is how we generally calculate probability. But generally this is a small number. With small numbers we generally don't calculate probability. To calculate probability, the statistics should be very huge. It's very large sample space only we calculate probability, but still the meaning of probability is similar. Yes, the probability we calculate in a similar manner that we have calculated here. But when we want to calculate probability, we take a large sample space instead of small sample space like this 100 or 20, something like that. We have to take a large sample space to say the probability. Okay, so probability is like average value of large numbers. But fine, 20 by 100, this indicates probability. This also indicates probability, but this indicates probability. So in statistics, what we are doing is we are multiplying whatever parameter we want to average. Here, marks is the parameter that we want to average. So whatever parameter we want to average, we are multiplying that parameter with its weights or statistics. Okay, and we are dividing with the total number, which is exactly same as whatever number we want to average. Whatever number we want to average, we are multiplying that number with statistics divided by total number, or it is exactly same as whatever number you want to average, whatever parameter you want to average, take the values taken by that parameter and multiply with its corresponding probability. Is it not giving the average value? This average value is exactly same as the statistical average that we were calculating in our lower classes. Yes, I hope you're following. So what should we do now when you want to average? Take whatever parameter you want to average, multiply with its weight, or multiply with its probability. Multiplying with weight or multiplying with probability, both are same. Okay, but when you are multiplying with its weight, you are dividing with the total number, which is effectively same as probability. Okay, Next time onwards, you don't need any formula to find average when weights are involved or probabilities are involved. So instead of giving this information, I'll say 80 students get, students get 80 marks with a probability of 0.2. 70 students get 70 marks. Students get 70 marks with a probability of 0.5. 60 students get 60 marks with a probability of 0.1. 50 marks with a probability of 0.1. 90 marks with a probability of 0.1. Instead of giving this information, if I'm given this information, then also I'll get the same answer. Instead of weights, probabilities are given. Fine. If the weights are given, also fine. If the probabilities are given, then also we'll get the same answer. Okay. So what I've shown you here is whatever statistical average we calculate in our lower classes, it is exactly same as the average that we calculate using probabilities. So that's why we call them as statistical averages. The average that we calculate with the help of probabilities is exactly same as statistical averages, because they are taking the help of statistics. From these statistics only we get these probabilities. Okay. So we call them as moments. We also call them as expectations. And since we calculate these averages or moments or expectations using statistics, the probabilities are also called as statistics only, because probabilities we calculate from statistics. So since we average the parameters using statistics, we call them as statistical averages also. Or we also sometimes they also call it as ensemble averages. There is another name for this, ensemble averages also they call. Statistical averages, ensemble averages, expectations, moments, they all mean the same thing. Okay, I hope you have understood by now. Okay, right. So this is the example to have a very commonsensical idea of what is expectation, what is moment, or what is average, statistical average. Okay, now we will get into the mathematics of it. The notation that we use is expectation of x. This is the notation. If x is a random variable, random variable takes different values with the different probabilities, right? Correct or not? So for example, random variable you can define it the way you want. For example, I'll say x is marks of a student, for example. Marks of a student. Okay. So for a particular student, a student has written exam and we don't know what is the marks. And I've defined the marks of a student as a random variable x. Now, what are the possible values for x? From 0 to 100, any value is possible. Correct? But do you know deterministically what value is possible? We don't know deterministically because it is random in nature. We don't know what will be the marks of the child. But from his, if you have the past data of his performance, if you have the statistics of his performance, then you will have some idea of what is the probability of getting certain marks. If you have past data, if you have his list of past marks, then if he's a good student, he got 90 many times, 80 sometimes, 70 very less number of times, 100 sometimes, something like that. Then you can understand that, okay, this student has more probability of getting 90, less probability of getting 100, less probability of getting 70, something like that. You'll have some idea, right? That information is what we call as statistics. From statistics, we get the probabilities. Okay. So if you want expectation of x, what it means is x is the marks of a student. Expectation of x means what is the expected marks of students? See this one? Expectation means expected marks. Actual marks we can't predict, no? Before the student result comes out, you don't know what is the result. Okay, and if I ask you how many marks he will get, then you can't say anything about it, because if you have the statistics also, you will say, sir, 90 marks he got a certain number of times, 80 marks he got certain number of times. But I'm not interested in all the details. I just want what is the expected mark. You can't tell the exact mark. Okay, what are you expecting? So if you want to tell the expected mark, you have to average. You have to average the parameter with the statistics. So how to average? Take that random variable, possible values of the random, whatever values it takes. So for example, in the previous example, 80, 70, 60, 50, 90. These are the values taken by the random variable with non-zero probabilities. Other values, the random variable takes with zero probability. Right. So whatever values are taken by the random variable, take that value. What should we do? We should multiply its weight with its weight. What is the weight? The probability. Multiply with its probability. And then just add it up. For different values, you do the same thing. See this one? Take the value, take the value, take the value, multiply with its corresponding probability, and just do the summation. Just do the summation. That's it. for different values of the random variable from minus infinity to plus infinity. If it is a discrete random variable, we can do it like this. Whatever I've written here is exactly same as what we have seen here. Whatever we have seen here, same thing I'm writing it mathematically in this format. There's same things, exactly same things. How about if it is a continuous random variable? If it is a continuous random variable, same thing you can do, but x takes continuous values, so that's why summation is not applicable, so you have to do integration. As simple as that. See, whatever parameter we want to replace, we have taken that and we have multiplied with its weight or probability, okay, and then we have integrated. Same thing we are doing here. Multiplied with the probability or weight, and then we are doing summation or integration based on if the random variable is continuous or discrete. So these two formulas are not for the same random variable. This is for discrete random variable x, and this is for continuous random variable. Okay, next. See this one, moment of a random variable is weighted average of values taken by the random variable. And what is the weight? Weight is the probability. We are doing weighted average of values taken by the random variable by using their respective probabilities. The weights are the probabilities. Okay, so that is the basic understanding of expectation of a random variable. Okay, now let us see a few more things. Expectation of x square. We want the average of x. Okay, that's fine, but we are not only interested in the average value of x or average value of the random variable, but sometimes we are interested in few more averages also. One such average is expectation of x square, or we also call it as mean square value. We also call it as mean square value. Mean of, expectation means mean or averaging. Expectation is average value or mean value. Expectation of means mean of squared value. We are squaring the random variable and then finding the average or mean value. So that's why we call it as mean square value. Very, very important parameter, which indicates power, total average power. Which indicates total average power. If the parameter that you're talking about here is a current or voltage signal, if x indicates current or voltage signal, then definitely expectation of x square. What does it represent? X represents voltage, then squaring means voltage square. Voltage square represents power kind of parameter, right? Power kind of parameter. Expectation indicates average. Expectation indicates average. Average squared value means power. It indicates power. Average power. So total average power. So don't say total, whenever you see expectation of x square, don't say average, total average power, because that does not make sense if x is not current or voltage. So let's say if x is marks of a student, then if x is marks of a student, then it does not make sense to call expectation of x square as total average power. Okay, it does not make sense. Only if x random variable indicates current or voltage, then if you call it as total average power, that is fine. So mean square value generally gives the total average power. Very good. So how about this one? Expectation of x gives us the mean value. We simply call it as mean value of the random variable x, or DC value also we can call it. If x indicates a voltage or current signal, we also can call it as DC value, or yeah, that's it. So if somebody says DC value or mean value, yes, they're talking about this. If somebody calls mean square value, yes, they're talking about this. So let me write the mathematical formula for this. So what do we want to average here? X square. X square is so for random variable x, okay, for random variable x, if x is a random variable, x square is also a random variable. If x is random, x square is also random, right? So what are the values possible for x square? All those values, you take them and you multiply them with the corresponding weights or probabilities and then do summation. If x is a discrete random variable, do summation. And if x is a continuous random variable, do integration. Same funda, same basic here. Here you want to average x, here you want to average x square. Whatever you want to average, take that, multiply with the corresponding probabilities, and then just do summation if it is discrete, and then do integration if x is continuous. As simple as that. Okay. Next, there is one more value that we are interested in generally, which is variance. We call it variance. We denote it like this. We call it as variance. which indicates, if you're talking about X is a random variable which indicates voltage or current, then it indicates average AC power. Average AC power. Okay, so what is the meaning of this? Variance meaning is, from this you can't understand any meaning, this is just the notation that we follow. So the meaning of it is, it is also average only, expectation of X minus X bar whole square. What is X bar? X bar is X bar means average. So expectation of X, there is one more way of writing expectation of X, which is X bar. There is one more way of writing this, which is X square bar. Instead of this E, if you put a bar on top of it, that also indicates average. So this is a different type of notation that we generally follow. Bar indicates average. So expectation of X minus X bar whole square means X bar is the mean value, subtract the mean value from the random variable and square it, and then average. You want to average this, okay? You want to average this. So the meaning, the definition for this is integration of X minus X bar whole square. Different values of X minus X bar whole square possible. Take that, multiply with the probability, and then just integrate if it is discontinuous, and do summation if it is discrete. And then just do summation if X is discrete. Okay, right, this is variance we call it, or it also indicates AC power if you're talking about voltage or current random variable, right? So we'll talk about the relation between these three. There is a relation, beautiful relation between these three terms: mean value or DC value, mean square value, and variance, right? So I'm moving on to the next slide. So let us explore the relation between these three parameters. So let us talk about mean square value now. Expectation of X minus X bar whole square, which is equal to, let us write expectation of X square minus plus X bar square minus 2 into small x into X bar. Okay, so what is its value? We'll explore. It's very easy now we can write it easily. Expectation of X square. In the next slides I'll talk about the properties of expectations. Okay, I'll talk about properties of expectations. So next time onwards, whenever you face this kind of situation, it will be very easy for you to deal with once I discuss properties of expectation. So expectation, now I'm applying on individual terms. 3 terms are there. So expectation of X bar square minus expectation of 2 times small x into X bar. See this one? This is expectation of X square or X square bar. We can also write as X square bar. Both are same terms. Plus, how about this one? Look at this and tell me. X bar indicates mean. Mean when it is squared, mean square, mean whole square. Is this a constant or is it a random thing? Is it a constant or random thing? I'll just go to the previous slide. See this one. This is random in nature, but once you apply expectation, has it become a constant or not? Random variable. X is a random variable. Yes, randomness is there in this. But once you apply integration, you are integrating with respect to the random variable itself. Once you are integrating with respect to the random variable and substituting the upper limit and lower limit, which are constants, then what is happening? This result will be a constant only. No, the x will be missing. The random variable is missing after applying expectation, correct? In this expectation also you can see same thing. You are integrating with respect to x, and after integrating, x is substituted with infinity and minus infinity. What happens? X will vanish, right? So the randomness will vanish. So point is, expectations are always, any expectation after applying expectations are always deterministic in nature. They are not random in nature. We apply expectations on random variables, we apply expectations on random things, okay, but after applying expectation, what we get is deterministic things, deterministic parameters. So expectations are always deterministic. See this expectation? We got a constant here. We got a constant here. After applying expectation, we get constants or we get deterministic things. So whenever you apply expectation, randomness is removed. There is no more randomness after applying expectation. Right. So this is a constant, correct or not? X bar means already expectation is applied. That expected value is a constant. After applying expectation, it's a constant. Constant squared is again constant. What is expectation of a constant? Anybody? Expectation of a constant is the same constant. See, what is expectation? Averaging. Why are we averaging? Because it is taking different value, that is why we are averaging. But when you are having a constant, there is no need to do expectation also, because you don't need to average, because it's a fixed value. So that's why whenever you apply expectation is always, expectation of a constant is always the same constant, no change, because there is nothing to expect here. Expect means why will you expect? Because when you are not sure, then only you expect, right? When I say what is your expectation of marks, if you know your marks already, then there is no need to expect. You can exactly say the exact value, correct? So for constants, expectation is the same constant, because this is not random in nature, this is deterministic in nature. Expectation of deterministic things is same deterministic thing minus. So there are two constants here, 2 and x bar, both are constants. Can we put these constants outside the expectation? Can we? Because if expectation means what? We are weighted averaging with respect to the PDF, probability density function. So if you do weighted average, so we will be doing integration or summation. So 2 and x bar are constants. Can we put this 2 and x bar outside the expectation? Because expectation is nothing but integration or summation. When you do that, the constants, we can put it outside the summation or integration, correct? Now look at this one. X square bar plus x bar square minus 2 into x bar. This expectation of x is also x bar. X bar and expectation of x both are same. So they are just different notations. They are just different notations. See this? X bar and expectation of x both are same. Right. So this is x square bar plus x bar square minus 2x bar square, which is finally x square bar minus x bar square. See this? 2x bar square, x bar square. If you add these two terms, it will be minus x bar square. So these two look similar. They are not exactly, they are not same. Okay. This is mean square value, we call it. After squaring, we are finding the mean value. After squaring, we are finding the mean value. This is mean whole square. There are two different things. They are entirely different things. We are finding the mean first and then square. But here we are squaring the random values first and then we are average. They are two different things. This indicates for a voltage or current random variable, this indicates DC power, because mean is nothing but DC value. Mean value or DC value both are same. So mean value, we call it as DC voltage or DC current. When you square it, we get DC power. So mean square value, as I already told, it will give us total power or total average power. Total average power, and this will give us average AC power. Average AC power. Average AC power. See this one? AC power, average AC power is equal to total power minus DC power. Correct or not? From the total power, if you remove DC power, obviously you will be getting AC power. Or we can also write it as x square bar is equal to this one on one side and this one onto the other side. Sigma x square plus x bar square. This is total power. This is AC power. This is DC power. Okay, and this is total power. Hi Shubhadeep, good morning. See, so this is the wonderful relation between the three statistical averages that we have discussed: mean value, mean square value, variance. Okay, so the sigma x square, we call it as variance, but the first order term version of this, the root of this sigma x is under root of variance. Variance, if you take a root of it, it will become a first order term. Variance is a second order term. Mean square value is also second order term, but mean value is a first order term. So first order version of variance, it is just root of it. We call it as standard deviation. We call it a standard deviation. Okay. We call it a standard deviation. Very good. So that is the understanding. Now, how about instead of these three values, instead of expectation of x or x square, is it possible to find expectation of some other functions of the random variable? Yes, it is possible. You can find expectation of any function of random variable. Let me say g of x is the function on the random variable x. What is g of x? G of x can be any function. I'm talking about general thing. G of x can be x square, x cube, x bar 4, x bar 5, sin x, cos x, log x, anything is fine. G of x indicates any function possible on x. If you want to find average of this function, because x is random, any function of x is also random, right? So we are trying to find the average of this random variable g of x. X is a random variable, g of x is a new random variable created using x. Now how do we average? Same process. Take g of x. G of x happens with the same probability as x, correct? So multiply with the probability of x, which is fx of x. G of x happens with the same probability as x. So that's why g of x, we are multiplying with the probability of x, because g of x has the same probability as x. Now, same thing. You want to average this, take that, multiply the corresponding probability, and then just do summation or integration based on the random variable if it is discrete or continuous. If it is discrete, just do summation. If it is continuous, do integration. G of x into fx of x dx, as simple as that. Any function of x, same process. Take that function, multiply with the PDF of the underlying random variable, and then just do integration or summation based on the random variable. Okay, right, that is the idea. Now let us write the properties of expectations. Very basic stuff, but very important stuff. Properties of movements of random variable or expectations of random variable. So that expectation operation is there, right? I'm talking about the properties of that operation. The first property, how about expectation of a constant? Expectation of a constant k. K is a constant, okay? So how about expectation of a constant? Is it not the same constant? So if you're not sure, you can apply the formula integration of k into fx of x dx. K is a constant, you can put it outside the integration. Integration of fx of x dx is 1. Second, expectation of a constant is the same constant, because expectation is you're trying to average. Yeah, if a constant is there, what will you average? It's a constant, averaged also to be the same constant. So expectation of a constant is exactly the same constant. Okay, next, expectation of a random variable plus constant. You can write it as expectation of x plus expectation of k. Expectation of k is k only. So if you add a random variable with a constant, you can separate it into two parts. Okay. Similarly, if there are two random variables x and y and they are being added, yes, you can write them separately. Expectation of x plus expectation of y. Okay. Same thing I'm doing here, but k is not a random variable, k is a constant. That's why expectation of k has become k. Next, how about expectation of kx? A constant multiplied with a random variable, what happens? See, this simply basic is, just go with the basics of expectation. What do? When you want to expect, take that function that you want to do expectation of, multiply with the corresponding probability density function, and then just integrate if it is a continuous random variable. Now can we write it as k outside the integration, because k is a constant, x into fx of x dx. Whenever they do expectation, just imagine it in terms of integration or summation. Is it not looking like k into expectation of x? Is that okay or not? See this? So k, we can put it outside the expectation. Next time onwards, whenever you are seeing a constant multiplied to a random variable inside the expectation, you can put that constant outside the expectation without any problem. K into expectation of x. The constants multiplied to the random variables can be put outside the expectation. Next, how about expectation of ax plus b? So I'm applying this property and this property together. We can write it as expectation of ax plus expectation of b. Okay, so we can write as a into expectation of x This expectation of B is B only, right? Next, one more. These are the basic things, very basic stuff, but very important stuff. So how about multiplication of two random variables? So this property does not talk about multiplication, but anyway, we can't write it as, we can write it as expectation of x into expectation of y only under certain situations. If x comma y are uncorrelated, yes, we can write. If x and y are uncorrelated random variables, then we can, this relation is valid. Or when x and y random variables are independent, then also this relation is valid. Okay, so we can't write, this relation is not valid if the relation between the random variables is uncorrelated or independent. If it is not uncorrelated or not independent, then this relation is not valid. So this relation does not hold correct always, it holds correct only under these conditions. Okay, this is the property of moments or expectations. Right. So let us solve some questions based on moments. Has a PDF as shown in figure. Find mean square value, find mean square value and variance. Okay, so let me give you the PDF. So this is the PDF. PDF shape can be anything. Process is same. This is 2. So this is 4. This is A, 2A. Find, I'll also ask you one more question. Find A as well. So this is the question. Let us solve it. So I've asked you 3 moments to find. One is mean, first order moment, mean square value, second order moment, variance, also second order moment. Right. So first let's find A. So we know this is PDF. Area of PDF should be 1. The property, basic property is area of the PDF should be equal to 1. So find the area of this, that should be equal to 1. So width is 2, height is A. Area of only this rectangle part is 2A plus area of this rectangle part is 2 is the width, height is 2A, 2 to the 4A equal to 1. So 6A is equal to 1, A should be equal to 1 by 6. So this is 1 by 6 and this is 1 by 3. 2A is 1 by 3. Now we got the A value. So whatever unknown parameter is there in the PDF, we got that. Next, let us find the mean value. So expectation of x, this is what is being asked. Mean value means expectation of x. So let's find it. How to find it? You want to find the average value of x. So how do you find it? Take that value, take the values possible in x, multiply the corresponding probabilities or PDF. Since it is continuous random variable, integrate it from minus infinity to plus infinity. That's it. So which is equal to integration of x into, what is the equation of fx of x? Equation is equal to a, or 1 by 6 is the height or equation from 0 to 2. Okay, so I'm substituting fx of x with the 1 by 6 or a from in the region between 0 to 2, plus from 2 to 4. What is the equation of fx of x? What is the equation of fx of x? Equation of fx of x is 2a or 1 by 3. I'm substituting that, simple math, plus from 4 to infinity, what is the equation of fx of x? It is 0 dx, plus integration from minus infinity to 0, see this one, fx of x equation is 0 from minus infinity to 0, so it is x into 0. I'm substituting fx of x with 0 in the regions from minus infinity to 0 and 4 to infinity. See this? So this part goes off, this part goes off because they are zeros. Next, how about this? 1 by 6 outside. If you integrate, it becomes x square by 2. Limits are from 0. So this is 1 by 3 times x square by 2. Limits are from 2 to 4. So which is equal to, so this is 1 by 12. X square is 4. 4 minus 0. If you substitute the limits, 2 square minus 0 square. Plus 1 by 6. 3 into 2 is 6. So it becomes 4 square. 4 square minus 2 square. 4 square is 16 minus 2 square is 4, which is equal to 16 minus 4 is 12 by 6, which is 2. 4 by 12 is 1 by 3 plus 2, which is equal to 5 by 3. Is that okay? That is the mean value, expected value. Fine. Now let's find mean square value and variance also. Let's find mean square value and variance. Expectation of x square we want to find, which is equal to integration from minus infinity to plus infinity. X square we want to average, so multiply with the PDF of the random variable and integrate. So from 0 to 2, we know the equation of fx of x from 0 to 2. From 0 to 2, the equation is 1 by 6 or a, and from 2 to 4, the equation is 1 by 3. In the remaining limits, the equation is 0. The same way we have substituted here, same way we are going to substitute here also. From 2 to 4, x square into 1 by 3 dx, plus in the remaining limits it will be 0. So it will be 1 by 6 outside. X square integration is x cube divided by 3, limits from 0 to 2. 1 by 3 outside, integration of x square is x cube by 3, limits from 2 to 4, which is equal to 1 by 6 3s are 18, 2 cube is 8, minus 3 3s are 9. Substitute, if you substitute 4 cube minus 2 cube, 4 cube is 64 minus 2 cube is 8. 64 minus 8 is 56. Okay, so this will become 4 by 9. 4 by 9. Once again, so this should be a plus. No, my mistake. So this is a plus. This is denominator is 9. 4 cube is 64 minus 2 cube is 8. 64 minus 56. 64 minus 8 is 56. Okay, so this will become 4 by 9. 4 plus 56 is 60 by 9. Right? 60 by 9. I think we can do some cancellation, right? 3 we can cancel. It will become 20. 20 by 3. That should be correct. If you got a different answer, let me know. I think the calculations are correct only. Next, how about the variance? Variance is what we need to find now. Variance is equal to expectation of x square minus expectation of x whole square. This is the relation. We can find variance using the basic process also. Expectation of x minus x bar whole square. The actual meaning of this is expectation of x minus x bar whole square. This is the actual meaning. So if you want, you can do integration of this and find it. That is one way. Other ways, we can take the help of the relation between variance, mean square value and mean value. This is the relation. This is total power minus DC power. So total power mean square value we just now found, which is 20 by 3, minus mean value we just now found in the previous slide, just 5 by 3. 5 by 3 squared. This is DC power. So 20 by 3 minus 25 by 9. So just 23 is a 60. 60 minus 25 is 35 by 9. That is the variance. Okay, it should be correct. Right? So we've done with the question. So we're able to find the mean value, mean square value, and variance of this function. Okay. Shall we do one more question? Let's do. So I've taken a different shaped PDF now, triangle shaped PDF. So shape of the PDF can be anything actually. It can be exponential, it can be any shape. Any shape, the same basics are valid. So let me say just 2 here. Let me say the height is A. Now let us solve the question. Let's first find A value. The area of the PDF should be equal to 1. So half into base is 2, height is A, it should be equal to 1. Which means A should be equal to 1. This value of A should be equal to 1. Only then the area becomes 1. Only then it will be a valid PDF. Now, let's find the mean value. Expectation of x is equal to integration of x into fx of x dx. What is the equation for fx of x? Tell me, can you tell me? So the height is 1. In 2 units, it has increased by 1 unit. So the slope is half x. Correct? Yes, slope is half x. And this equation is valid only from 0 to 2. And in the other value, for other values of random variable, the equation of PDF is 0. Right, this is the equation. Let us substitute that equation. Half x is the equation. Half x is the equation of the PDF. Expectation of x is integration of x into fx of x dx. I am substituting in place of fx of x dx half x. That is valid only from 0 to 2. I am just writing directly. I am skipping one step here. So instead of writing the basic formula, I am just directly writing this step. I hope you can understand that much. So which is equal to half outside, x square is there, integration of x square is x cube by 3, limits from 0 to 2. So 1 by 6 outside, so 2 cube is 8. Fine, that's it. 4 by 3 is the mean value. Next, how about expectation of x square? Expectation of x square is integration from 0 to 2 x square into half x dx. I'm skipping a step here. I'm not writing the basic formula for this, which is given here. Okay, I'm writing the next step. I'm writing the substitution step because this is the second question. First question I've discussed in very detail. So now this is 1 by 2 outside. So what is here? X cube is there. X cube is there, which if you integrate, it becomes x power 4 by 4, limits from 0 to 2. 1 by 8 outside. So x power 4, substitute with 2 and 0 is 2 power 4. 2 power 4 is 16, right? Minus 0, which is equal to 2 units. So mean square value is 2 units. Next, variance. We know a variance relation between mean square value and mean value. So mean square value minus mean whole square. Mean square value minus mean whole square will give us variance. So mean square value is 2 units minus mean whole square is 4 by 3 whole square. Which is 2 minus 16 by 9, which is 9 2s are 18. It's 2 by 9. Is that okay? 16 by 9. 9 2s are 18. 18 minus 16 is 2. 2 by 9. Yes, correct. Yes, that should be fine. So we figured out mean square value, and variance. Let me ask you one more question here. How about expectation of a x square? Okay, let me call it as 2x square plus 3. How about this? So if you want to figure this out, just apply the basics of properties of expectations. So you can put this 2 outside, and you can write as 2 times expectation of x square plus expectation of 3 is 3 only. We already know expectation of x square, which is 2 units. So 2 2s are 4 plus 3, which is equal to 7 units. Okay, we can solve it like this. Fine. Similarly, one more also we can discuss. Okay, let me go to the next slide. Okay. Okay. So like this, any modification instead of 2x square plus 3 some other function. Also you can solve it with the help of basics of expectations and properties of expectations. Okay, right, so this is what I wanted to cover regarding moments of random variable or expectations or statistical averages or ensemble averages of a random variable. So with these basics you should be able to solve any question based on moments of random variable. Okay, so here I've taken only two examples of PDFs. One is shape like this and a shape like this. Any other given shape, just write the equation of it. As long as you know the equation of it, yes, you can substitute here. Yes, you can substitute in the formula of expectation of x or expectation of x square, and you can get the solution. Instead of this shape, if it is some other shape, here the formula, here the equation will be different. That equation you can substitute here or here, and you can get the answers. Any shape, it is the same basic. Okay, fine. So here I have given you two homework questions. So easy to solve. It hardly takes less than 2 minutes if you have understood the concept clearly. So if you are able to solve the questions, you can post it in the comment section. You can post the answers in the comment section. Okay, so if you have not subscribed to our channel, kindly subscribe, and if you liked the content that I've provided in this session, don't forget to press the like button. Okay, right, so we'll meet again in tomorrow's session. We'll discuss another concept based on random variables. So I have taken 3 sessions based on random variables in this week, and I'll be taking 3 more sessions based on random variables, three more different concepts based on random variables in the next 3 days. And all the sessions are at 8 a.m. So don't miss the sessions. And if you have any doubts, you can post it in my Telegram group, which I've provided at the start first slide. Okay, fine then. So take care. See you next time tomorrow. Until then, bye bye.